Now that we've talked about the quantum numbers, we're actually going to apply them to something that we call the electron configuration. So the electron configuration describes the arrangement of all the electrons that an atom has. So each electron will exist primarily in a region that is defined by one of the orbitals. It might not always be in that location, but it has a really good odds of finding an electron there. So since every element has a different number of electrons, each has a different electron configuration. So that means based off of an electron configuration, we can determine what element is being looked at. So remember, atoms tend to be in the lowest possible energy level. And so that means these electron configurations are going to be ground state electron configurations because this is the lowest energy arrangement that could possibly exist. So in order to do electron configuration, when you hear of electron configuration, you should think of the order that electrons fill orbitals. And it has to go in the same order for every element. And so once you learn that order, it goes fairly smoothly. And so there's a couple rules in addition to learning that filling order. So the Aufbau principle says that all lower energy levels must be filled with electrons before electrons can be added to higher energy orbitals. This is referred to as building up. So to review from yesterday, when we have a notation like this, the 1s, this first one reports the energy level, or it's another way to refer to it as N, your quantum energy level, or your principal energy level. The S represents your orbital, and specifically it represents the orbital shape. So remember, the S is a sphere, and P is that dumbbell shape. And then we have the D's and F's, which are a little bit more complex. So when we talk about Aufbau's principle about filling energy orbitals from the bottom up, we look at this 1s and notice how there's only one circle here. That's representing that there's only one possible orbital. And that makes sense because it is in the S orbitals. Here we have 3, and because that's a p orbital, that makes sense because there's 3 possible orbitals when we talk about the p sublevel. Then we look here, we have a d sublevel, and the d sublevel can hold up to 5 orbitals, 5 possible orientations and shapes. And then lastly, we have the f orbital in sublevel, and that has up to 7 orbitals. Now, remember, each orbital, and it doesn't matter what shape it is, can only hold 2 electrons. So once 2 electrons get placed in this first 1s orbital, then we can place any electrons up in this 2s. Again, maximizing at 2 electrons. And so notice how each arrow that I drew, one is up, one is down, and that is to represent your spin. So remember, there's 2 possible values of spin. You have plus 1/2 or minus 1/2. And the up arrow represents one of those, and the down arrow represents the other. So what is the correct energy filling order? And that's when we can look at this diagram. We get this diagonal rule filling chart. Really super helpful if you have the chart, but unfortunately you're not going to get to use the chart on your tests and quizzes. So we'll go quickly through how to use this chart, and then we'll look at your periodic table, because your periodic table is set up to give you this information as well. So we start here, and you follow that red line. And every time you come across an energy level with an orbital shape is what orbital will get filled. So first off, we start with 1s. And then we can either have 1s1 or 1s2. And this is because since there's only that one orbital, this 1 indicates the electron. So this would be the first electron to get placed, and this 2 represents the second electron to get placed. So once those 2 electrons get placed, then you keep following the red, and then you loop back to immediately the next red line. Again, you follow that line down, and you come across a new orbital and energy level. So the next one to be filled would be 2s, and you have to put the first electron in. Then if you have another electron to place, it would be 2s2. So each of these little superscripts is keeping track of your electron count. So if you have an element that has 5 electrons, you can see that we have 1 electron, 2, 3, and 4 electrons placed. And so we need to keep going. So to keep going, you would again follow the arrows through, loop back around to the next red line, follow it down, and your next energy level and orbital that would be filled would be 2p, and then it would be a 1. So, and this would keep going until you've got all of the electrons placed that you need to be placing. Now, like I said, you don't get to use that chart on your tests and quizzes. So if at this time you have a periodic table that you want to mark up, you should take it out. And yes, you should want to mark it up. So the first thing that we're going to mark up on this periodic table is your energy levels. Your energy levels are represented by the horizontal rows that go down the periodic table. 1, 2, 3, 4, 5, 6, 7. So if you needed to quickly look and say, if I said, what energy level is carbon in? You find carbon, and you can see that it is in the 1, 2, second row, so that means it's in the second energy level. Likewise, if you looked at strontium, as you can see, is in the 5th energy level because it is in the 5th row. So that's your energy levels. Next, we're going to show you where your orbital shapes are located. So we first have this chunk. Then our second chunk we'll do in purple over here. We have a third chunk here in the middle. And then our last one will be down here with this lone segment. So the green section represents your s orbitals. I think we'll just put it here. S is in green. Then we have in purple is our p orbitals. The blue is the d orbitals. And then lastly, the red represents the f orbitals. So then we need to talk about our different quantum numbers. So the next quantum number that we talked about was our angular momentum number. And our angular momentum number was represented by the letter L. And this indicates the shape. So when we had an L of 0, it represented the S sublevel. When we had an L value of 1, it represented the P sublevel. So the angular then momentum number that corresponds with D is 2. So notice how I'm writing it over the areas where they are in the periodic table. And our last angular momentum number could be 3, representing the F block. Then we have our magnetic number. And this is represented by that M sub L. And this gives you the orientation around the nucleus. So with that, again with the S, our only possible option here is 0. With our P sublevel, our possible orientations are -1, 0, or +1. And so how that works out on the periodic table is that this first column is the -1s, second column is 0, +1, and then our next, it just repeats itself, 0 and +1. So there's kind of a line of symmetry as we go through, and I'll do that here in black. As you can see that it starts back over at that -1. And all of these columns, or all of these sections, can be divided perfectly in half to get that line of symmetry. So we have then our D block, we need to label our magnetic number. And so our D block options, oh sorry, I'll write that a little nicer. Our possible options are -2, -1, 0, +1, +2. So again, start on the left, -2, -1, 0, +1, +2. Reach that line of symmetry, so start over at -2, -1, 0, +1, +2. Lastly, in our F block, our magnetic numbers could be -3, -1, -2, -1, 0, +1, +2, or +3. And so I'm going to write them below so I have a little bit of room. We have -3, -2, -1, 0, +1, +2, +3. Reach that line of symmetry here, so start over at -3, -2, -1, 0, +1, +2, and then +3. Last, we have our spin. And our spin, I think I'll just do in black again. So our spin number can either be +1/2 or -1/2. And that really corresponds to that line of symmetry that we drew. Everything to the left of that line will be +1/2 for the spin. Everything to the right will be -1/2. And that goes for all of the blocks. Oops, sorry, -1/2. So I don't know, maybe it works better to +1/2, -1/2. And then down here too, we have plus 1/2, and then this way is minus 1/2.